team of Ulani,
Okay,
please.
this robot is made from parts. Here's down part. There are motors, omnivores, and ultrasonic sensors. And there's a lot of cables. Then the dribbler. In the upper part is motor of dribbler and battery.
About the battery is an Arduino is board from the other side. Here is the Arduino.
Port to connect with computer, and this here's a board connected with Arduino, and there are all of the things up are connected here. Here's a display, pressures, compass, and camera. And the omnivore is made from a 3D printer, and there are two parts. I don't want to put it up and down, and there are little wheels on it.
Is there anything that you have improved since the last year?
What of this one? What of this one?
No, this one. So it's the same.
Yes, because when we know the it will be now, it was 3 weeks before, and for 3 weeks we haven't really time to yes, upgrade and got some components.
We are working on a new robot.
All right.
One part is did now, but that's all.
Are there any questions from the audience?
What do you think are weak sides of your robot? Or maybe what do you want to improve?
We are going to make a better camera and change the 4 wheels to 3 and bigger wheels with it will be 2 omnivores and there will be 48 the little wheelies for the better turning.
So you plan to completely build from scratch a new robot?
Why three-wheel? Like, what do you see me as improvement? Like maybe what will it change?
It will be wheels and the camera. We want to make camera with
Yeah, but like you are going to make it wheel from four-wheel robot. Like, what will it change on the behavior on the field or?
from 4-wheel to 3-wheel, and I think it will be to no. This we must do this. We must take apart this robot a lot of times, and it's very complicated and easier.
because the cables are
Yes.
a lot.
A lot of cables and a lot of cables. And one cable is wrong, or robot is wrong.
Okay.
All right. Thank you a lot. So now Team LNX.
So we've been trying from September to build a whole new robot, but there was not enough time since the deadline was shortened and the competition time by 1 month. So that's kind of unlucky, but we can do about it. So we had to bring back the 2 old robots, which were used in the meantime to practice with the new parts as 360 camera, which was mounted here, which is exactly the same type as the one over here with 360 mirror. That was made, but we had to take it down because it didn't quite fit the rules of the competition. But, so That's why you don't see it here. We added LiDAR on the other robot. You can see this one, it's late, and we even used it in our matches. It was used to get a really accurate position as a goalkeeper, which managed us to defend lots of goals within the competition, and we are planning to also add it to the new one. But since we were doing from September, since we were planning on making the new one, and we never like really planned on bringing this to the competition even, or maybe one, but yeah. But you can see this is the new version, which is kind of like the first prototype of it. There's a lot of cables, we are planning to shorten it down, the cables and everything. So there will be actually space for like dribbler and kicker, and here for the LiDAR. But yeah, I spent like the first like 2 months just developing the dribbler, which was never used for the competition in the end, so it was kind of waste of time, at least for this round. But I believe for like European and the next rounds, it will be really worth it, and we'll make 2 robots with the new designs and truly see them shine. Also, these robots are built with this new robot is built with BLDC brushless maximum motors. Also, we have 2 3S batteries, so we are taking advantage of the new voltage rule, which is up to 48 volts. So we have 22 nominal voltage. Also, I don't know, we have the new Raspberry Pi 5 over here, so we can have 2 cameras at the same time. It will probably be quite handy. And that's it probably for this robot. The old ones are nothing special really, the same thing that was here last year, just for power motors, which are really terrible because of the high P ratio or something we cannot do all vectors of movement of the robot or even all speeds, and it's just terrible in general. And we have BN055 as the compass, which is same for both robots. And that's it. Yeah. Whatever. We have 2 STMs over here on the bottom or on the top. And here we have Kinsey as the secondary.
I would like to ask about the LiDAR. So do you use it during the games?
Yeah, we use it.
And do you use all 360 degrees or just some kind of field of view?
Yeah, if you're calculating position, also based on everything.
So even from back?
Well, yeah, from those that we actually
Yeah,
get,
it is
but
kind of, but it.
yeah, some of them are
That's why I wanted to ask, because there's a cable behind.
I think the angle is very small.
Yeah. Right. Any other questions from the audience about
How did you make a mirror?
We tried to CNC it, but since we polished it by hand,
Mhm.
it was distorted. So we ordered a vacuum one, and the shape we tried to make the shape that doesn't distort the field at all. So like we can see rectangle as it is.
Mhm.
And it kind of works, but it has to be very precisely made. So
Where did you make it? Like, where did you order it?
we asked some little guy here in Bratislava.
Okay.
He made it for us.
But the first version was done by you.
Oh yeah, the first version was
Yeah.
done on late in the workshop.
Yeah.
You have 3 different versions of it.
Yeah, the first was done by Matusz himself, but without the vacuum, so it was kind of not fitting right onto the 3D printed mold of it. It was kind of not bad, not right. Then I did that one, but it wasn't perfect because of the workshop tools were kind of old.
Yeah.
So you first made the mirror and afterwards you buy the camera? You bought sorry.
We try to find like really one-to-one spec ratio, so you don't get distorted image from the camera. Like always.
What is the cost of the lidar?
Around 100 euros.
100
maybe.
euros.
Yeah. You can
And how it's called?
buy the second one.
LD like a
LD19.
LD19.
Yeah, it's LD19 and you can find it.
Yeah.
But you can buy it for like 50 if you don't want the USB converter and stuff.
And maybe what's the precision? Did you know like position? Did you do any like measurements like what's the real value? Or-
It's like accurate. The main problem is that it only has like 10 updates per second, so
It's really slow.
it's very slow. You cannot like go full speed and
Mhm.
rely just on
Yeah. Okay. And do you do any like middle sampling or like predicting the value that will go next and like
no.
okay.
Not yet.
Not yet. Okay. Thanks.
All right, thank you.
Hi, we are from Croatia. Our robots are they're now 3D printed, but we ordered like metal plates to have more stability. Because right now the forwarders are not on the ground, so let's say this one just spin freely, and then the robot doesn't just do it on a straight line; it goes like this. It has a, it's quite simple. It has a Teensy 4.1 is the main controller. It has two OpenMV cameras and a mirror. The front one has a wide angle lens to see more of the field. The front one is mainly just for precisely targeting the ball when it's in front of him, and the only mirror is for when the ball is anywhere else. There are four joint max motors on the bottom, and we made this line cylinder ourselves. It just 32 photo transistors and LEDs, and we are using a multiplexer to shorten it to only bits or 6 bits. We also have four lidars, one pointing to each side, to detect when we are near the wall, because we don't really like. I think it's a better like idea when you're on your line anywhere to actually check which way you can move, not to like see if you see a line on the right, you need to go to the left, because then if your robot like overshoots, gets past the line, then he will see the left line and he will try to go to the other side, which is outside of the field. So we actually just check if there's any line anywhere, and then we see on which side there's free space to move. So here, we will not move here because there's a wall here, just on the opposite side. And what if there are no other robot? Well, then he just stays here. He won't go this side. And then he can move forward. Let's say if the ball is here, if he wants to move forward, he will just go there. Nothing's really stopping him. Only if the ball is slightly outside, like if the angle is slightly off to this side, then the robot will try to go to like near the wall, but he will detect that there's something here and he won't go there. Okay, that can maybe happen if like there's a wall here and another robot here. He won't go there, but that's really a tricky situation anyway. So not really important. Okay, so this is just for temporary because we didn't have time to make zero and we forgot to make something plastic. So on the next generation it will have a driller and a kicker, and this camera will just be a little bit more higher, and there will be 8 lidars instead of 4, like two pointed to each side. Forward, backward, left, right, and then at 45 degrees. Because in the dribble, the room here doesn't have to stay pointing at the same goal all the time, in the same direction. And then when you spin, if I want to check if there's a wall here, I can't use these lidars because they're pointing at an angle. So I have when I have more lidars in each direction, I can more reliably check if I can go there or not. I don't use the physics lidar because it has to have a Raspberry Pi to be controlled, and I think that's a bit too complex for this right now. I just like to keep it as simple as possible.
You built these robots from scratch since the last competition?
I mean, yes, it did. I mean, we have kept this same line sensor because the new one I ordered didn't come in time. But most of the robot parts are actually the same, so like the box regulators, the main controller, the motors, the cameras, everything is basically the same, just there's this different layout, and it's a little bit more sturdy, and the biggest change is the camera, the mirror.
Is there any communication involved?
Not right now. There is a port for like a Bluetooth module or anything, any kind of communication, but for now we didn't have time to do anything. We are planning to do some kind of communication, at least like one robot can communicate with the other one about the ball position, so the other one doesn't actually have to see the ball to know where the ball is. But we haven't done that yet.
Any questions from the audience?
The LiDAR, you can have it connected to the STM32. Like, yeah, there would be issues with maybe processing it, but you can connect it.
To the
Yeah, to the TNC. Because you receive data from the UART. But yeah,
can the LiDAR like directly outputs.
yeah, you get like the direct LiDAR output from each. Yeah, you just get it on serial communication.
I see that your motors are not all 45 degrees.
Well, in order to have like a wider dribble, there has to be more space in front. So we didn't put the motors in a cross, but the front ones are like a little bit rotated outwards. And the movement is basically the same, but there's more space here, so that there's a wider like capture area where the dribbler can catch the ball. But it has to have a dribbler to move, so now it's just
What's the angle between the front two motors?
the front one is like 60 degrees, so 120.
Okay.
You did the mirror by yourself?
Yes, it's like it's just in its own shape. We feel like we bought like a circular mirror thing. I think it's a 4 in wide, and then fold it up in the one body. And we just cut it along with the radius and fold it. So now it has this like line. We put it on the front because in the front we always have another camera, so it doesn't matter if the only camera sees it or not, because the main camera will see it. So, but yeah, on that like line, it's not really good.
Alright, if no other questions, then thanks. In front, then.
Yeah, so these are my robots. They look like similar, but they actually aren't. The biggest parts on the boards are at the same place because the space on these robots is really small, but they have a different camera system. This one is the new version and this one is the older. The new version has higher frame rate and also higher resolution and like better lenses, let's say, because these two cameras had the same, but I changed it to 200 degrees and 60 degrees to maximize the efficiency of the robot. And the second biggest difference is the lower PCB, which now contain only from 1, not from 5 I think, yeah, from 5. And that's a lot better because now I don't have these gaps when I am trying to detect the line. And also I have one improvement on that where I am using WS 1228B LEDs, which are separately addressable, so I can adjust the brightness of every LED. So when I am moving to another carpet or another field, I can only make the average of the values of two phototransistors and calculate the brightness of the LED. So it can play like anywhere and on every color. But now the robot is higher because these smaller ones can be placed higher. So I had to adjust the dribble and kicker, but that's no problem. It's only a little bit weaker. I'm using TNZ 4.1 and Raspberry Pi, where Raspberry Pi is processing the image and sending only the angles of the line and ball, not line, ball and goal to the TNZ 4.1. And I also made some improvements in motor drivers and schematic, but that can be seen because they are only small parts. That's all I think.
Do both robots have the same tactics, or is there a goalkeeper?
Yeah, they have the same tactic. A little bit different because the new one can move faster because it can detect the ball faster, but the tactic is the same. And now I'm on the Robocup competition for the last time, but if I would come next year, I would like to improve the tactic and also the camera vision, where I would like to use 360-degree camera and also one in the front, like Alanix had or has.
What led you to use like overtop camera, like instead of using mirror or something like that? Maybe.
Now I'm using the fisheye lens, so it can the field of view is 180, I think, degrees. So I can see all the field and something above, I think, like a few centimeters above the ball. But it's really distorted, and these cameras have like the ratio of the image 16:9, and I would like to use 1:1. And also it has like the blue borders around the image. I don't know what is doing it, but it has it, and I have to filter it.
Did you find some nice way of filtering it? Or?
No, I'm just cutting it. Because the image on the edge is really distorted, so it isn't usable, so it's useless.
We had the same problem.
And it is also on some edges of the field, so it's somewhere here. So I don't.
So it doesn't matter.
Yeah.
Any other questions? No, then thank you. Now let's continue with the light bites. So please, all the light bite teams, bring your robots.